What is counting? Counting has an important application in computer science and also in mathematics. How many telephone numbers in a given country or a given network are possible can be determined with the help of this principle of counting. What is this pigeonhole says? If k plus 1 objects are placed in k boxes, for any k belongs to n plus, at least one box contains more than one object. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in this session, I am going to take the second part in the unit 1. In first unit, the second part is basic structures. So what we are going to study here? So in basic structure, that is, we are going to study regarding the counting principles. What are the things we are going to study in this counting concept? Basics of counting. So what are the basics of counting and what are the uses and why we are using the principle of counting? And very important is a pigeonhole principle. Pigeonhole principle. This is very important concept, and the permutation and combination, and also the binomial coefficients and the combination, binomial coefficients and the combinations, then generating permutations and the combinations. These are the things which we are going to study in this counting principle. So basic principles of counting, that is basics of counting, and very important concept is pigeonhole principle, and then the permutations and combination and generating the coefficients of permutations and combinations. That's it. These are the things which we are going to study in this counting principle. Let me start with the basics of counting in this session. So in this session, I am going to take regarding the basics of counting and the problems based on pigeonhole principles. Right. Now let us come to the counting. So what is counting? Counting has an important application in computer science and also in mathematics. So this plays very important role in the field of science, that is in the field of computers as well as in the mathematics. So here, let us consider, for example, determining the complexity of an algorithm. So, to determine the complexity of an algorithm, we are using the concept of counting, and also computing the discrete probability of the same events. So, to compute the discrete probability of the same events, we are going to use the principle of counting. Further, this counting can be applied to compute for computing. For example, let us consider, for example, how we are going to use the principle of counting in the field of computer science. So, how many passwords of a given length and specified constraints used symbols are potentially possible with the help of this counting. And the very important is how many different IP addresses, how many possible IP addresses in a given protocol. For example, IPv4 and IPv6. So, how many different IP addresses are possible in a given protocol, and how many different telephone numbers in a given country or a network are possible. So, how many telephone numbers in a given country or a given network are possible can be determined with the help of this principle of counting. So, how many different driving license plates in a given country are possible? How many driving license plates? Okay, how many driving license plates are possible in a given country? That can be determined with the help of this counting principle. Now, another few more examples for this counting principle can all be applied in the probability of any event concerning counting, such as any of the above example and the similar. The number of operations to be executed by a loop, that is nested loop, in a computer program, that can also be explained with the concept of counting problems, and how many different chemical molecules within a given properties are possible. That is, how many different chemical molecules can also be explained with a given property, with the properties of this counting. So that means how many different chemical molecules with a given properties are possible. So how many different ways of finding the path in a given graph are also possible with the help of this counting. So these are few examples where we are using the principle of counting. So these are the fields where we are using the principles of counting. These are few small examples. Now let us come to the abstract representation of the counting problems. How to represent the counting problem? So that is called the abstract representation of the counting problem. So most of the concrete counting problems can be represented as some frequently encountered general, abstract and counting schemes. That includes, what are those? Product rule and sum rule. So very important is the product rule as well as the sum rule. Then the very important is pigeonhole principle and the inclusion and exclusion principle. We are using the concept in product rule as well as sum rule. Then pigeonhole principle, inclusion and exclusion principles, counting permutations and combinations, that is without repetition or with repetition, and generating the functions. So generating the functions. So that means frequently encountered general abstract counting schemes can be includes product rule as well as the sum rule and the pigeonhole principle, inclusion and exclusion principles, counting permutations and combinations without or with repetitions, and generating the function. Okay. Now let us come to the next concept, general counting method. So usually the most of the practical counting problem consists of two steps. So for the first step is nothing but the recognizing the problem, that is recognizing what the general abstract pattern, that is nothing but or a combination pattern, represent the practical problem under study to be solved. Second, apply the appropriate techniques to solve the given problem. So there are two methods in solving the most practical method. We are going to adopt two steps. The first step is recognizing what the problem is, and the second step is applying the appropriate technique to solve the given problem represented by the discovered pattern or combination of patterns. So we have to study first, then apply the proper technique to check whether discovered pattern or a combination of patterns. What is the combination of the given problem? Okay. Now let us come to the next very important concept, that is called the pigeonhole principle. This is very important concept. Now listen, what is this pigeonhole says? If k plus 1 objects are placed in k boxes, for any k belongs to n plus, at least one box contains more than one object. Say for example, let us consider this itself is an example. So let us see in this diagram how many holes we have. We have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 holes are there. In this box we have 9 holes. Assume that there are 10 pigeons. So here we have 10 pigeons, and this box containing 9 holes. So we are going to the pigeons in all these 9 boxes, 9 holes, in such a way that if we place one pigeon in each box, at least in one of the box we will find more than one pigeon. That is called the pigeonhole principle. That means if k plus 1 objects are placed into k boxes, for any k belongs to n plus, at least one box contains more than one object. If there are 9 holes and we are going to place 10 pigeons in that pigeonhole, at least one of the hole will contain more than one pigeon. See here, this 9th hole contains 2 pigeons. So that is, if you divide 10 by 9, how much you will get? 1 point something you will get. Since this divisibility is a greatest integer function, you know greatest integer function which is greater than or equal to is called the greatest integer function. So therefore in this box we are going to get, we can accommodate 2 pigeons, that is more than one pigeon in that particular box. So we can accommodate any, we can place the pigeon anywhere in these boxes from 1 to 9, but one of the box will contains more than one pigeon. That is called a pigeonhole principle. See, so pigeonhole principle in mathematics, the pigeonhole principle states that if we must put n plus 1 or more pigeons into n pigeonholes, then some of the pigeonholes must contain 2 or more pigeons. That is, n pigeonholes, in n pigeonholes, if you put n plus 1 or more pigeons into n pigeonholes, then some of the pigeonholes must contain 2 or more pigeons. That is the statement of this problem. Let us consider, so I will explain this by one more example. Let us consider there are 3 pencils and 2 boxes. We have how many pencils? 3 pencils and 2 boxes. Let us consider 3 pencils and 2 boxes are there. So these are the 2 boxes, box 1 and box 2. How many pencils are there? There are 3 pencils. So we are going to put the 3 pencils in these boxes. We can put P1 here and P2 here. And one more pencil is left that can be placed either in P1 or P2. So that means of these 2 boxes, one of the box will contain more than 1 pencil. That is called the pigeonhole principle. So if you divide this 3 by 2, what you will get? 1 point something. This is a greatest integer function that is nearly equal to 2. That means one of the box will contain at least more than 1 pencil. That is called the pigeonhole principle. So that means if k plus 1 objects are placed into k boxes, for any k belongs to n, at least one of the box contains more than 1 object. So here in this pigeonhole we are placing 9 pigeons, 10 pigeons in these 9 boxes. At least one of the hole will have more than 1 pigeon. That is easily observed from this diagram. Hope you got an idea. This is very important concept in counting principle. The very important concept is pigeonhole principle. Right. Now let us take few problems based on this. Now let us come to the example. If kn plus 1, this is the generalized pigeonhole principle, generalized pigeonhole principle. If kn plus 1, where k is a positive integer, kn plus pigeons are distributed among n holes, then some of the holes containing at least k plus 1 pigeons. This is the statement for generalized pigeonhole principle. If k plus 1 pigeons are distributed among n holes, then some of the holes contains at least k plus 1 pigeons. Now let us take an example. Among 8 peoples, how many peoples are there? 8. Among 8 peoples, at least 2 of them have birthday on the same day of the week. Second example, there exists at least 2 persons that have the same number of hairs on their heads. These are all examples for the pigeonhole principle. Now let me explain by considering a small example. Let me consider a problem. Now let us come to this problem. If 6 colors are used, how many colors? The number of colors are 6 colors are used to paint 32 homes. So we are going to paint 32 homes using 6 colors. Show that at least 7 homes of them will be the same color. This is simple concept. See, how many homes are there? 37. How many colors are there? 6. If we divide 36, this you will get 6 point something. So 6 point something, which is greatest, nearly equal to the 7, the greatest integer. Since it is the greatest integer, therefore 6 plus 1, that is 6 point something, is nothing but the 7. So 37. So here 37 by 6 is 6, which implies 6 homes of each color we are going to apply, but the remainder 1 will be the color from the remaining 6. So therefore we have 7 homes may have the same color. So since if we divide this 37 divided by 6, so this is 6.16, the greatest integer, which is nearly equal to 7. So therefore at least 7 homes may have the same cycle. Okay, that's it. Okay, see here. So 6 homes of each colors, and the remainder 1 will be the color from the remaining 6. So therefore 7 homes may have the same colors. 7 homes may have the same colors, and the remaining 6 will have the different colors. So listen, sorry. The 7 homes may have the same colors, and the 6 homes will have each colors of 6 colors. Each of 6 colors. Now let us come to the next problem. Find the minimum number of teachers in a college to be sure that 4 of them born in the same month. That means 4 must have the same date of birth. born in the same month means they will have the same date of birth. So find the minimum number of teachers in a college to be sure that 4 of them are born in the same month. Now here, since in a year how many months are there? N is 12, 12 months are there, and what is given? K plus 1 is given to be N is equal to 12, and K plus 1 is given. How many teachers are there? 4. Therefore K is equal to 4 minus 1 is equal to 3. K is equal to 3. See here, Kn plus, according to the definition, Kn plus 1. Kn plus 1 can be written as K into N plus 1 is nothing but K is 3 into what is N? 12 plus 1. So that is 36 plus 1 is equal to 37. So Kn plus 1 is equal to 37. That's it. So at least find the minimum number of teachers. 37 number of teachers in a college will be born the same month. That's it. Okay. So that means here N is nothing but the number of boxes, and the number of pigeons here considered as a 4. 4 is the number of pigeons. So there are 37 number of teachers. Okay. Now let us come to the next problem. Prove that among 1 lakh people, there are 2 who are born on the same time. So among 1 lakh people are there, 2 of them are born in the same time. Among how many people are there? 1 lakh people. What is required to find is 2 of them are born in the same time, on the same time. Now let us consider, let us represent P as P1, P2, P3, etc. P 1 lakh with a set of people. So 1 lakh people are there, P1, P2, P3, etc. P 1 lakh people are there. Let H is nothing but the set of all hours in a day. That is H1, H2, 24 hours are there. H1, H2, 24 hours in a day. So 1 lakh people, and how many hours are there? 24 hours in a day. By extension of the pigeonhole principle, there exists at least P by H persons during the same hour. That is nothing but 1 lakh divided by 24. If we divide, that is nearly equal to 4167. 4167. That is P by H person during the same hour. Per hour. This is per hour. So 4167 per hour. Okay. So persons during the same. By extension pigeonhole principle, there are at least P by H person born during the same hour. That is 1 lakh divided by 24 means 4167 peoples are born per hour. This is per hour. Now let us calculate per minute. Now if Q1, Q2, Q etc. number of peoples born per hour are 4167, and M1, M2, M2 per minute. So per hour how many minutes? That is per hour 60 minutes. 1 hour is equal to 60 minutes. 1 hour is equal to 60 minutes. So therefore per minute M1, M2 etc. M60. Then the number of persons born in the same minute. In the same minute, how many persons are born? 4167 divided by 60. That's it. 4167 divided by 60 will give the 70. So the number of persons born per minute, 70 persons born per minute. See, first we have calculated the number of persons born per hour. Again, number of persons born per minute. So per hour it is 4167, per minute it is 70. Now again let us consider R is equal to R1, R2, Rn etc. R7 and S is equal to S1, S2 etc. S60. That means number of persons born in the same second at least. So in a week, 7 days. So R is equal to 7 and 1 minute is equal to 60 seconds. 1 minute is equal to 60 seconds. So number of seconds 60. Therefore the number of persons born in the same second at least are 70 divided by 60. That is nearly equal to 2. 70 divided by 60, which is nearly equal to 2, since it is the greatest integer function. So what is 70 by 60? Again it is 1.16. The greatest integer value of 1.16 is nearly equal to 2. So the greatest integer value of 1.16, which is nearly equal to at least 2 persons are born That is 70 by 2 is equal to the number of persons born in the same second, at least 70 by 60 is equal to 2. Now, what is to prove? Prove that among 1 lakh people, there are at least 2 persons born in the same time. So, here, therefore, just find out the number of people born per hour. Again, calculate the number of persons born per minute. Again, calculate the number of persons born in 1 second is 70 divided by 60. That's equal to 2. That is to be proved. So, the number of persons born in 1 second out of 1 lakh people is 2. That is, will have the same time. Will have the same time. So, number of persons born in the same second of among this 1 lakh people will be 2 persons. 2 persons will born in the same second. In the same second out of 1 lakh. This is what the generalized pigeonhole principle. Hope you got an idea. Now, let us come to the next problem. Show that if we allot 26 rooms to the students in a PG hostel from the room number from 1 to 15. So, both inclusive, at least 2 allotments are consecutively numbers. So, that is, what is to prove here means, show that if we allot 26 rooms, 1 to 26 rooms to the students in a PG hostel from the room numbered from 1 to 50, both inclusive, at least 2 allotment are consecutively numbered. 2, how many? 2 allotments are consecutively numbered. Now, listen to me here. Let us consider the number of rooms are 1, 2, 3, 4, 5 up to 50 rooms. How many rooms are there? 50 rooms, 1 to 50. And how many allotments are there? A1, A2, A3, etc. up to A26. How many allotments are there? 26 allotments. Now, according to the pigeonhole principle, then we have 50 divided by 26, that's equal to 2. 50 divided by 26. So, 50 divided by 26 is nearly equal to 1.92. So, this is the greatest integer function. So, this is nearly equal to 2. That means at least 2 allotments are consecutively the numbered. That's it. Okay. So, 150 divided by 26 will give the value. That's it. So, here since there are 50 rooms, how many rooms are there? 50 rooms, and their allotment are from 1 to 26. Therefore, 50 divided by 26 will give 2. That means here at least 2 allotments are consecutively numbered. That's it. Now, let us come to the next problem. A box contains 10 blue balls and 2 red balls. A box contains how many blue balls? 10 blue balls and 20 red balls, 8 green balls and 15 yellow balls and 25 white balls. How many balls must be chosen to ensure that we have 12 balls of the same color? Okay. Now, very simple problem. Here, what is how many types of balls? Blue, red, green, yellow and white. So, there are n is equal to 5 types of colors we have. And according to this, how many k into n plus 1 is equal to 12. So, that is how many? A box contains 10 blue balls, 20 red balls, 8 green balls, 15 yellow balls and 25 white balls. How many balls must be chosen to ensure that 12 balls of the same color? So, here n is equal to 5 and k plus 1 is equal to 12. So, once if you know k plus 1 is equal to 12, easily we can find out the value of k. So, k plus 1 is equal to 12. Therefore, k is equal to 12 minus 1 is 11. K is equal to 11. That is, according to generalized pigeonhole principle, kn plus 1 is equal to k into n plus 1 is equal to, what is k? We have k is equal to 11 into n. N is equal to 5 plus 1. That's equal to 11 5s are 55 plus 1 is equal to 56. Now, so here the minimum number of balls must be 56 balls will be ensured. So, how many balls must be ensured means 56 balls should be there. Kn plus 1 is equal to 56. Kn plus 1 is equal to 56. That means minimum 56 balls must we have, so that 12 balls will be of a same color. In that 12 balls will be of a same color. This is very simple concept. So, the formula which we are going to use to find is kn plus 1 is the formula which we are going to use to solve this problem in pigeonhole principle. So, that's regarding the concept on a pigeonhole. So, just you have only the basic concepts of a pigeonhole principle and simple examples based on a pigeonhole principles. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.